So hello and welcome friends to our channel Entromech, and here we discuss about basic mechanical engineering concepts and how we can apply them for the practical purpose in industry. So in our previous sessions we have seen what are the different types of sensors which are widely used in the industry, what are inductive sensors, how they work, then how to select them. So in this session we will discuss about the capacitive sensor. So let's see what is the working principle and how it works. So we have seen the inductive sensor which works on the principle of induction. Now here we have a capacitive sensor and it works on the principle of capacitance. So here you could see the sensor structure and it creates the electrical field, and whenever some part comes into the nearby area, the capacitance changes, and this change in capacitance is sensed by the sensor and it gives the output accordingly, right? Now the question arises that whether this capacitive sensor can be used for detecting metals, say non-metals, plastics, or any kind of material, because we have seen that in case of inductive sensor we can only detect the conductive materials, right? So the main advantage of capacitive sensor is it can sense any kind of material. You could see here it can sense glass, cloth, say metal, plastic, paper. So it has a huge variety of materials that can be sensed, and along with that it can also sense the liquid. That means it does not only sense the say bottle, but it also senses the liquid present in the bottle. So this is a very huge advantage of capacitive sensor. Here we see that the target, as target approaches, it changes the capacitance, right? You can read more about what is capacitance, what is dielectric constant of the materials, so you can get more idea about it. But this is the basic principle, that the capacitance of the circuit changes, and that's how the sensor gives the output, right? And if we place say a water inside a metallic container or a non-metallic container or plastic bottle, so the water has very high dielectric constant, and because of which it is easier to sense the water inside a metal tank, inside a plastic bottle. So that is one big advantage of the capacitive sensors. So let's see the Omron we have seen, which is one of the largest sensor manufacturer. It is huge, has presence in industrial automation field. So here we have gone to the Omron site. You could see the products, different huge variety of products offered by the Omron. So we will go into the products. Then we have sensors, switches, safety components, and so many things. We will go into the proximity sensors, right? And here we have cylindrical, rectangular, and here we have capacitive sensors, right? So we will go into the capacitive. Now here you could see different types of categories like long distance type, adjustable sensitivity, then we have cylindrical proximity, which is general purpose, then we have flat proximity sensors which can be mounted on the tank. Liquid level sensor, you could see the application which we were discussing, so they can be easily mounted on the tubes. So these are like liquid level sensors. uh, so this is how it offers a huge variety, and we will see the cylindrical sensors say, and it is come up with M12, M18 and M13 model. So these are the sizes, and they have fixed sensing distance, requires no sensitivity adjustment. So let's see the lineup. Here we have the sensing distance like 4 mm, 8 mm and 15 mm, you could see here, right? Then we will see the specifications, the model and its sensing distance is mentioned over here with the tolerance value plus minus 10%, right? So you can see the other electrical parameters. You can see conductors and dielectrics detectable objects they have mentioned, right? So you can read out the information here, and let's see the dimensions. So you can see what are the dimensions, the cable lengths and other parameters for the mounting purpose. The most important part is the catalog, because catalog contains a large amount of information. So let's go on to the catalog. Here you could see again the same information, right? And the model name, so how to order the model, so that is also important. And here we have the different say graphs which are given influence of sensing object size and material. So depending on the object size also it changes. So side length of the sensing object they are given, and the distance up to which it can sense. And you could see the grounded metal, then non-grounded metal, glass, phenol. So these different type of materials which the sensor can sense, that has also mentioned over here. So you can read the graphs, and on the basis of that you can select the proper sensor, right? So this is all about capacitive sensors, how they work, and how you can get the specification of these sensors, how you can say order the sensor from the site, what is its ordering code. So all these things. So let's see what is the difference between the inductive and capacitive sensors. So we have seen that inductive sensors can detect just the magnetic metals, and it is based on the magnetic field. So capacitive sensors based on the electric field, and they can sense, you can see liquids, metals, solids, right? Then the detection range, if you see, the inductive sensors offers a huge range like from zero point 0.8 to say 100 mm, but capacitive sensors offer less range like 2 to 50 mm. Then both are non-contact detection, we have seen both have good sensitivity, both are robust and accuracy. If we see, the inductive sensors are good, but capacitive sensors can give the false triggers. And the switching frequency of the inductive sensor is higher as compared to capacitive sensors. So that means it can sense with, say, it has a higher switching frequency. That means if the object comes into the proximity and goes out of the proximity, and if this happens very fast, even though in that case the inductive sensors gives the output at that faster rate, but the capacitive sensors gives the output at some lower speed. So that is the switching frequency. So this is all about the inductive and capacitive sensors we have covered up till now. And if you have any doubts, please write into the comment section and we can discuss over there. Until then, stay home, stay happy. Thank you.